Hi, seventh graders. This is our first recording of our live video, and I wanted to say hello and that I miss you all, and I hope that you are being safe and not going out in big public areas to get catching the coronavirus. It's been a crazy time. So this session is going to be on the review packet for Chapter 6. So what I would like to do today, this is part 1. I'm going to hold part 2 in a different session. This will be questions number 1 through 11, and I will be going through the odd questions. My goal for you, I know that spring break is next week, so the goal for you would be to complete the review packet questions number 1 through 11 by Monday, that would be March 30th, or Tuesday, April 1st. And then part 2, the remainder of the questions, would be completed by Wednesday, April 1st. And then I'd like to hold a live class-in session so you could ask me any questions about the review packet, and then I will be sending out the test on Friday, and you need to complete it by April 3rd, which is Friday. Actually, you'll probably send it out on Thursday, so you have a couple of days to complete it. So if you have any questions in the meantime, feel free to email me about anything. Be checking your school email every day starting March 30th, because that is what I'm mainly going to be communicating with you from. And also be checking your Google Classroom daily as well, because I'll be putting materials on there. And I hope everybody's had the opportunity to get Zoom downloaded onto their computer. For those of you who were unable to pick up your books, I think there were a few of you, don't worry, I have copies, scanned copies of all the pages you're going to need to complete for homework. And I am also putting this review packet on with this video on Google Classroom. So I hope that answers some of your questions. I know this is going to be a little weird at first. It's different than class, but I think that many of you are really going to like it because you can pause the video, you can rewatch the video. It'll give you an opportunity to learn at more your pace. So with that said, I would like to start our review. So my first thing I'm going to do is share my screen with you so you can see my screen. And I want to make sure that I am on. So this is your review. So the first page is the standards, and the standards that we're covering are going to be EE1, which is adding and subtracting and factoring and expanding linear equations, which we've been working on. So I know it's going to be a little bit non-fresh because you'll have had a week off, but I think you'll catch up really quick with remembering how to do it. And then E2 is going to be able to construct equations. The inequalities part is what our next unit's about. So don't worry about the inequalities part until the next unit. So to begin with, we're going to go through all of the even problems. I'm going to give you some hints too on the odd problems as well. So you want to get your paper out. If you need to pause the video to get your review packet out, or if you need to print it out, it's on Google Classroom next to the video. Go ahead and do that. And then when you're ready, press start and we will continue. Okay, so question number 1. Mary makes blankets and ceramic vases. Just want to pull my tools up there. She operates 2 booths at a craft fair to sell the blankets at one booth and the vases at the other booth. The fee for the booth where she sells the blankets is $200 plus $6 per day. The fee for the booth where she sells the ceramic vases is $75 plus $5 per day. So when you get a long question like this, the first step is always to underline your numbers. Rarely are they going to give you numbers in a problem that you're not going to use. Occasionally, word problems will throw in those extra numbers to kind of throw you off track. But for the most part, you're going to use most of the numbers in the problem. So I'm going to start by underlining the important things. So we're going to underline $200 plus $6 per day. We're going to underline $75 plus $5 per day. And I'm also going to underline a couple key words, blankets and vases. Now, when I have this, my next step then is going to be to, let's pull up this thing here too, is going to be to write an equation for each situation before I combine them. Because the question is asking us for letter A, write the expression for how much both booths, so I'm going to underline that as well. I'm going to underline both booths will cost for the same number of days. So I'm going to put myself down here. So my first step is to write an expression, right? So I have blankets and I have vases. Now I need an equation for the blankets and I need an equation for the vases. So if I look over here, the blankets is going to be $200 plus $6 per day. So what that means is it's going to cost me $200 just to rent the booth. And then it's going to be $6 for every day that I rent the booth. So if I rent the booth for 1 day, it's going to be $6 for that day. If I rent the booth for 2 days, it's going to be 6 plus 6 or $12 for the day. If I rent the booth for 3 days, it's going to be 6 plus 6 plus 6 or 3 times 6. So my rate is going to go up by $6 for every day. So now what I want to do is make sure I understand what my variable is going to stand for. So first I want to put I'm going to put the goal. Goal is to get the variable by itself. So that's always going to be our goal when we're solving problems. Now in our case, they're not asking us to do that yet. What they're asking us to do is to write equations. So we're going to make our variable be D, and it's a good idea to make your variable represent what you're looking for. So in our case, we're talking about days. So D is going to equal number of days of booth rental. Now, with my 200, pull that up again, my 200 plus my $6 per day, I know I have that flat fee of plus 200, but I also have that rate of $6 per day. So that's going to be my $6 times the number of days plus that $200 fee. So that is the equation for my blankets. Now vases is going to be similar, but we're going to go to the $75 plus $5 per day. So for vases, how would I set that up? Well, what's the fee for the vases for the one-time booth rental fee? Correct, that is $75. And what is the daily rate? Correct, $5 per day times the number of days plus the $75 fee. So now we've got two equations. We've got an equation for blankets and we've got an equation for vases. However, the question wants us to write an expression for both booths. How much is it going to cost her to run ceramics and how much is it going to cost her to run blankets? So we're going to combine the two together. So we're going to have 6D plus 200 plus 5D plus 75. Now I can't leave it like that because I have to combine my like terms. So if I look at terms that are the same, I can combine the coefficients where the letters are the same. So I have a 6D and a 5D. So I can combine those and then make a different color here. I can combine the constants that do not have a variable with them, the 200 and the 75. So what is 6D plus 5D? 11D. Plus, what is 200 plus 75? 275. So my equation for letter A, write an expression for how much both booths will cost with the same number of days is going to be 11D plus 275. That is my expression. Now, 1B is asking something different. How much does Mary pay for both booths for 7 days? So now what they want us to do is let's draw a picture, take this 7 and change my color back to red and plug it into the D, because we want to know how much it's going to cost her after 7 days. And remember, we said there was that rate initially for blankets. It was $6, and then we added the vases for $5 a day. So it's going to cost her $11 a day to run both booths. So we're going to plug that in, and I might as well put it right here. It's going to be 11 times 7 days plus the $275 flat fee. And then it's a matter of calculating that out. And remember, order of operations, you're always going to do the multiplying and dividing before you're going to do the adding and subtracting. So we have to do 11 times 7, which is 77, plus 275, which then, if you do the math, I would do it vertically so you can line your numbers up correctly. You would end up with 352. So we could say, and just scoot this over a little bit. Oops. We could say then the final answer would be, it will cost Mary $352 for 7 days to run both booths. Try to say both booths 3 times fast. See if you can do it. Okay, so that's the answer to that one. So take a look at that. Pause the video if you need to. Work out the problem for yourself, and then when you're ready, press play, because I'm going to erase this in a second. Okay, that was number 1. Number 2 is very similar. You're going to have to combine the like terms, so I'm going to let you try that one on your own. Number 3, now we have to use something. It's a property. See if you can remember what it's called. I'll tell you the first letter. What property did we learn about? Way back 2 weeks ago. D-I, anybody got it now? I'm sure you all said it by now. Distributive property. Correct. So this is an example of using the distributive property. So I'm going to go over here, start a new page here. So we have 9 times 2p minus 10z. Remember, what we're doing with the distributive property is we're taking the number in front of the parentheses and multiplying it by each number inside the parentheses. So what I'm doing is multiplying 9 times 2p. That would give me, 18p minus 9 times 10z, 90z. So that's it. So that is our answer, and I'll put that in here. 18p minus 90z. Can't solve for any letters because this is just an expression. It's not an actual equation yet. So that's how you use the distributive property. Hopefully it's coming back to you. All right, number 4, you're going to do on your own. That's factoring. Number 5 is also factoring, so you'll get an example of how to do one of them, and then you can go back and try number 4. So I'm going to clear my drawings now, and we're going to move on. So we have 4x plus 48. So now what we're doing is actually just the opposite of the distributive property. Factoring is the opposite of the distributive property. So we are going to pull out something. So the way to pull something out is to find the greatest common factor of the two coefficients. of the two coefficients. Remember, the coefficient is the number in front of the variable. So to find the greatest common factor, this is something you would have done more in 6th grade, but just to refresh your memory, we're going to take all the factors of 4. So we have 1 times 4 and 2 times 2. We're going to list them. And then we're going to take all the factors of 48, and we're going to list those. So we got to think of all of them. There's a lot. 1 times 48 is always a good starting point. Looks like 2 will work. 2 times 24. 3 will also work. 3 times 16. And if you don't know that, you can divide 3 into 48 and see that you get 16. We also have 4 times 12. And last but not least, 6 times 8. Oops, and now we have to find all the common factors. So I'm going to go through and I'm going to circle all the common factors of both 4 and 48. So I've got a 1 on both. I've got a 4 on both. And I've got a 2 on both. And now I'm going to pick the greatest one. So between 1, 2, and 4, which of those is the biggest, the largest, the greatest? 4, correct. So that's going to be the number when I'm factoring that I'm going to pull out. So on my original problem of 4x plus 48, I'm going to slide up here and erase my circles as I move up. I'm going to pull out a 4. So if I divide a 4 into each coefficient, let's see what I get. So I'm going to divide a 4 into 4 and a 48 divided by 4. So 4 and 4. So if I divide 4 by 4, I should get 1, right? So I'm going to pull out my 4, and I'm going to be left with 1x. But remember, we dropped the 1 in front of a letter, so it's just x. Plus, what's 48 divided by 4? If we forgot, we can go back and look at our factors here. 4 times 12 gives me 48, so the answer would be 12. So that is my factoring. I'm just taking the 4 out, and I'm left with an x and a 12. So if you're not sure if you did it right, you can always go back and use the distributive property to check it. So if I was to use the distributive property to check it, pull that up, I would remultiply 4 times x and 4 times 12 and see if I get my original problem. And if I do that, 4 times x is going to give me 4x, and 4 times 12 is going to give me 48. So yes, I end up with my original problem over here that says 4x plus 48. So we know we did it right. So I'm going to put the answer in there for you. The answer is 4 times x plus 12. There. So go ahead and pause the video if you need to, and then press play when you're ready, and we'll move on from there. I'm clearing all my drawings, and we're going to move down to number 6. Number 6. 6 is a little bit of a tricky one. It's tricky because it's got negatives and it's also got fractions in it. So let's take a look at that. I'm going to start a whole new screen here. So I'm going to rewrite it as x minus 2/3 is equal to negative 6 1/3. And I'm just going to highlight that this is negative. No, let's see, I'll probably put an underline on it. So I'm just going to highlight that this is negative, like that, so we can see that. Now, we are actually having to solve for x. So remember I had said in the beginning, the goal is always to get the variable by itself. Now is the case where we're going to use that. So how could I get x by itself on one side of the equals? Well, if you remember, we need to use inverse operations. So what do I have going on the side with the x? Right, I have a negative 2/3 or a minusing 2/3. So what I'm going to need to do up here is I'm going to have to add, which is the opposite of subtracting, add 2/3. But remember, you can't just add 2/3 to one side, you have to add 2/3 to the other side. So I'm going to put it underneath the 2/3 there. And then I'm going to draw my line. There we go. And I am left on this side with x plus, what's negative 2/3 and positive 2/3? Should be 0, correct? So these guys here should eliminate themselves. And then on the other side, that's the tricky part now. So I have a negative, remember how I circled that negative there? Or I mean underlined it. That negative 6 1/3, and then I'm adding 2/3. I'm gonna put a plus so you know that's adding. I'm adding 2/3. So whenever you're doing subtracting or adding with fractions, you have to separate your fraction side from your whole number side. So this is a negative 2/3, and this is a positive 1/3. So I'm going to end up with, on the right side, with the fractions of what? I have a negative and a positive. I'm going to end up with a negative 1/3. Okay? And then I'm just going to do the 6 part. The negative 6 is going to be added to nothing. So it's going to be 6, negative 6, and 1/3 is my final answer. Now, the last step is to just drop that 0, because x plus 0 is just x. X is equal to negative 6 and 1/3. Now that might seem a little bit tricky. So this is one of these problems where if I'm taking a test, I'm going to want to check this one just to be sure that I did it right. So this would be the answer there, but I want to check this. So how could I check this to make sure that I did this correctly? Well, I would take this negative 6 1/3, if I can draw this way over here, and plug it in for x and see if I get a true statement. So let's go ahead and do that on this one, just because it was a harder problem. And that was problem number 6. So check down here. We're going to plug that negative 6 1/3 in for x. So negative 6 1/3 minus the 2/3 should equal negative 6 1/3 if we did it right and we had the right solution for x. So I'm going to rewrite that over here because I always do fractions vertically. Negative 6 1/3, oops, minus, this is the tricky part, minus, why is it doing that to me? I probably have to do this. Minus 2/3. It does not like that. Glitch in the program. Minus 2/3. There we go. Okay. I don't want it to be over the entire thing, but you get the general idea. So now if I was going to take 1/3 minus 2/3, I should get, remember we're also splitting it again. You got to split the fraction part from the whole number part. So 1/3 minus 2/3 is going to give me a negative 1/3. And then I have my negative 6 minus nothing. So I'm just going to slip that in there back so it lines up well. And I'll erase this line in between. So the answer is negative 6 1/3. And that is negative 6 1/3 is equal to negative 6 1/3. So the statement is true. So I found the correct solution for X. Okay, go ahead and pause the video if you need to work that problem out. And when you're ready, I'm going to clear the drawing and move on to the next problem. Okay. Number 7 is going to be similar to number 6, except you don't have to deal with the messy fractions. Just decimals, which I think is sometimes easier. So we'll go on to number 8. So now for number 8, we're going to be solving for the letter Y. For looking at negative 1/4 Y equals 64, if you notice, we no longer have adding or subtracting in there. So whenever you have a coefficient in front of a variable, it means to multiply. So we have a multiplication situation going on here. So we need to, again, the goal is to get the variable by itself on one side of the equals, correct? So to do that, we are going to use inverse operations. So using inverse operations, what is the opposite of multiplying? Correct, dividing. When you divide with fractions, because this is a fraction, 1/4, when you divide with fractions, it's the same thing as multiplying by the reciprocal. Dividing fractions, and we had learned this back, I don't know, a couple of units ago. Dividing fractions is the same as multiplying by the, oh, now it's going to go too far to my left, so I'm going to move it back. Multiplying by the reciprocal. I probably spelled that wrong. AL, there we go. It's the same as multiplying by the reciprocal. So I look at what I've got. I've got a negative 1/4 Y equals 64. And I need to say, well, what is the reciprocal of negative 1/4? Correct, it would be 4/1. So because there's a negative here, I'm going to multiply by negative 4/1. But I can't just do it to one side of the equals. Whatever I do to one side, to keep it balanced, I need to do to the other side. So now I need to multiply by negative 4/1 on the other side. Now, it's hard to see because it's going across, so I'm going to rewrite it just so you can see how this looks in terms of numbers on the top and numbers on the bottom. Multiplying that by negative 1, it's a huge negative 1/4. I'm going to fix that. It's too big of a line. Negative 1. Okay. And then I have a multiplication sign in between. And normally we're using dots now because x's start to get confusing when you use it for times versus a variable. So now if I look at that, I'll change my color here. And the negative 4s will cross off and the 1s will cross off. And because I multiplied by a negative times another negative, the negatives will also cross off. And then I will be left, and I want to change my color back to red, equals, and I'll write that the same over here, 65, it's supposed to be a 5/1 times, I'll use a dot just so we don't use the x, negative 4/1. So now, the 1s are just going to be anything over 1 is just the number. So now all I'm going to be left with is the x on this side, or 1x, but we can drop the 1. 1 times any number is just the number. And now we are left with 65 times negative 4. And if you are to do the math, 65 times negative 4, go ahead and calculate that out. And I calculated that out to be, I believe, 256. Yes, negative 250, it's supposed to be a 5, 6. So I'll go ahead and put that in the answer here. Y equals, oh, I had X there. See, that's because I put a times. Let me go back and fix that. That should be a Y. See, that's my own fault here. And this Y should have been stuck right here too. And then erase that and that, make that a Y. Now it still looks like an X. It's my lovely drawing here. Y. There we go. All right, so Y equals a total of negative 256. And again, if I wanted to check that, I'm not going to check this one, but you can try that at home. You're going to plug in the negative 256 if you want to check it in for Y and see if you get 64. If you do and you get a true statement, then you've done it correctly. Now, number 9 is going to be very similar, except with decimals. So you're going to use the same methodology when you're doing number 9 as well. So go ahead and pause the video if you need to, and then I'm going to clear the screen and move on. Okay, we are now on number 10. This will be our last one for this part of the video. So for number 10, we're going to read it, and I'm going to just move this down so we can start a whole new page. A pond is getting fuller during a huge rainstorm. As the water level rises, the height of the water increases at a rate of 3/4 of an inch per minute. Write and solve an equation to find how many minutes it will take for the lake to be 3 feet higher. Note, 1 foot equals 12 inches. So again, I want to go and I want to underline the important numbers in my problem. I have the word rate of 3/4 of an inch per minute. That's going to be important. I also have 3 feet higher is going to be important. And I also have this little note here. This is going to be important as well. 1 foot is equal to 12 inches. And now what is my question? I'm going to circle that in blue so you can see it. So my question is, how many minutes, oh, I'm going to work, let's undo that. How many minutes will it take for the lake to be 3 feet higher? And you have to also write an equation to do that. So I'm going to go over here and I'm going to put my necessary numbers in. I have a rate. Rate equals 3/4 of an inch. And I have 3 feet. We want to know when it gets to be 3 feet higher. So what I'm going to need to do first is go back over here and take a look at this. Note 1 foot equals 12 inches because my rate is given in inches per minute, not in feet per minute. So I have to convert my 3 feet here to inches. So if I want to do that, I know that it tells me that 1 foot equals 12 inches. So if 1 foot equals 12 inches, 2 feet is going to equal 12 more inches or 24 inches, and 3 feet is going to equal another 12 inches or 36 inches. The quick way to do that is to take 3 feet times 12 inches, which will give you 36 inches as well. So you can either do by adding or you can do it by multiplying. Once you've done your conversion, now you're ready to write your equation. So we know that the 36 is going to go, that's like your total, that's going to go on the right side of the equals. And then on the left side, we're going to have our 3/4 of an inch per minute. So I'm going to use M because M will stand for minutes. So I'll put that up here. M is going to equal minutes. Minutes. There. Small m. Usually variables are always small letters, not capital. The computer likes to put everything capital at first. So 3/4 m equals 36. So I'm going to write that over here under the equation. 3/4 m equals 36. That is my equation. Now I have to solve that equation. So then it's just a matter of using inverse operations to get the variable by itself. So this is a multiplication equation, 3/4 times some amount of minutes, giving us 36 inches. So the opposite of multiplying is dividing, but dividing is really multiplying by the reciprocal. So I'm going to multiply by the reciprocal of 3/4. What's the reciprocal of 3/4? 4/3 to both sides. Don't forget, you got to do it to both sides. Whatever you do to one side, you do to the other. And now this is another one of those situations where it's hard to tell what's on top, what's on the bottom. So I will draw. We have 4/3 times, I'll put a dot this time instead of an X, 3, because last time that messed me up, 3/4. And then we can't forget the M is still there, equals, and I'm going to rewrite this in a better way of seeing it too, like 36 over 1 times 4/3. Okay, now I'm going to see what I can cancel out. So my 4s will cancel out each other, and my 3s will cancel each other out, leaving me with just a 1. On this side, 36 will be divided by 3, 12 times. Oh, I got to write a 12 here. Hold on a minute. 12 times, and my 3 will cancel out and become a 1. So now, go back to my blue color. I'm left with 1m. Remember, m means minutes. It's a really bad m. 1m equals 12 times 4. We can drop the 1 in front of the m, so let's drop that. We're left with just m equaling. The answer will be, what is 12 times 4? M is equal to 48. Right? 12 times 4, 48. So that means our answer is, it will take 48 minutes for the lake to be 3 feet higher. That is the official answer to the problem. Okay? All right, and then number 11, not going to do that one with you, but I will give you a hint on that one. So the hint for that one is going to be, hint, boiling point goes on the right side of the equals when you make an equation for number 11. Okay, I'm going to come back. Hello, back to you. So now your goal is to complete questions 1 through 11, the first part of the review packet, and you should rework all of the odd problems I did on the video. You should rewatch it if you need to, or rewatch parts of it, whatever you need, and do the evens. And I will be posting another video soon of the second half of the review. And then at that point, I would like to have a live session where you can ask questions on any of the questions on the packet before the test. So have a wonderful day in Cyberland out there. We'll see you soon. Bye.